Hello and welcome to part 2 on Chapter 6, Wi-Fi Technology. I think I mentioned at the end of the last video that I was going to talk about how to turn your access point into a jammer. And I don't want to get into too much detail, but I'll point out two things. One is on a typical, and you'd want to do this on an older access point that you've got at home, but these antennae are replaceable. They just spin off. I don't know if I can do this real fast, but yeah, they detach, and you can add more powerful antenna to the box. Or the other thing you can do is just download a copy of DDWRT. It's replacement firmware, and so instead of using Linksys or Cisco's firmware, you replace the firmware with something that much more closely resembles an actual managed access point. And you'll see some new controls that you didn't have access to before, such as boosting the signal gain. And if you did it on the same channel as somebody else's, whatever happens, happens. And typically the channels that access points in this 2.4 gigahertz range are going to use are channels 1, 6, and 11. And we'll talk about why those three in particular in just a second. Be aware that the 2.4 gigahertz range is not just for Wi-Fi. There are other commercial and residential devices that are in this band. Unfortunately, sometimes microwave ovens, they're not supposed to, but they'll kind of creep into this frequency. Originally, cordless telephones, when they first came out, I think they fixed this problem now, but you could get a 2.4 gigahertz phone. Well, that was a problem if it was broadcasting on the same channel. But let me show you the reason why we have three channels. There are a total of 14 channels that we can use for Wi-Fi. However, they all so 1 and 2 kind of overlap with each other. 1 and 3 kind of overlap with each other. 2 and 3, 3 and 4, 4 and 5. You can see the overlap, but there are only 3 places in this part of the spectrum, in this, within this band, where the channels don't overlap at all. There's a clean signal here with no overlap, a clean signal here with no overlap, and a clean signal here with no overlap. This refers to the width of the band. It's a 22 megahertz band. So when we say 2.4, notice that it's a range. So 2.412, 2.41, I can't even read that, 7, 2.422. So there's a range. The channels themselves cover a little, kind of a tiny little range of frequencies. But the test-worthy thing here is 1, 6, and 11 are the 3 channels that you want to stick to. It'd be, I don't know anybody that uses another channel. It'd be just goofy. 1, 6, or 11. Whatever your neighbor's using, use a different one. Here's where I need to, let me stop and figure out if I can draw. I've actually never done this before, but we're going to give it a whirl. So let's imagine you've got, this is the area of an access point. Isn't that a pretty access point? That's supposed to be signal kind of radiating out from the access point. So if this is the area that it's transmitting in, and we set this to channel 1, let's make that a pretty looking 1, and because we don't want people to drop signal when they move from this area to this area, we want there to be a little bit of overlap with the second access point. And because we can't transmit on the same channel 1 because of this overlap area, we're going to make this one 6, channel 6. Now again, if people are going to wander down to this area, they're going to pick up this access point instead, and this is going to be on channel 11. Now, repeat the pattern. So for example, I know this looks like a looks like a happy face now, but that's an 11. Here, let's do 11. So if we want another access point here, what channel would that have to be on? Well, 1, so it doesn't overlap. That's a terrible one. How about this one? What does this have to be? Well, obviously this has to be an 11. Now it gets a little trickier now. This is all on the second floor of the building, and I go up to the third floor, and I want one up here. I can't use one directly above a 1. I'd have to make this a 6 and kind of spin the whole thing around to accommodate, so the pattern repeats in the same way, but it's staggered. Staggered's a good word. So that's what we're doing here, and that's the way all in the 2.4 gigahertz range. This is how you have to lay out your access points. Whew, drawing is tedious. I miss my whiteboard. So there are some limitations to the 2.4 gigahertz range, namely that you've only got a choice of 3 channels. It wouldn't be great if we had more channel options. Well, that's what the 5 gigahertz range gives us. Now, a 5 gigahertz radio's just the technology is a little more expensive. The distance can be shorter, because remember I said anytime you're broadcasting at a higher frequency, you're going to run into more problems with attenuation, with absorptive attenuation in particular. And then deader shadow zones, that's not a word. I have no idea what a deader shadow zone is, but shadow zones and dead zones are a bigger problem in the 5 gigahertz range than the 2.4 gigahertz range, because it's a higher frequency. Deader, it's not a word. Anyway, we have a lot more channels with 802.11n, which uses the 5 gigahertz range. So 802.11g and n use the 2.4 gigahertz range. We've got our 3, 1, 6, and 11 non-overlapping channels. And if we're using a 5 gigahertz range, as with 802.11n, we're going to have up to 140 channels. Yay! Now, we still have overlap between the channels, but there are 24 channels now that are completely clean, completely non-overlapping. So that gives us a lot more choice with the 5 gigahertz range. So in that regard, it's better. Whether an access point is working with the 2.4 gigahertz range or the 5 gigahertz range, the principle is the same. A frame comes in on 802.11, either G or N or AC, we'll talk about, and the access point has to deliver the packet at layer 3, but it's going to strip it out of this 802.11 frame and shove that packet into a new frame, an 802.3 frame. 802.3, which is Ethernet, which is plugged into the switch. So again, an access point understands 2 different protocols. Some more vocabulary we need to be comfortable with. This is different with Wi-Fi than with straight Ethernet. You have something called a basic service set, a BSS ID. To my way of thinking, there's no difference between a MAC address and a BSS ID. The basic service set ID is the physical address of the access point. So if you want to think of this as the MAC address, that's great. The basic service set is the MAC address. The SSID, which you're probably used to changing on your home access point, where you can give your network a name, right? You name it something. The SSID is the name of that access point. But when you get into a situation where you've got multiple access points, like we do on campus, we have many access points, as you'll discover in homework assignment number 5. Many access points, but just a handful of SSIDs. In fact, the SSIDs are getting ready to change now from WPA, SIUE WPA to EduRoam, for example. If the SSID is consistent, the BSS ID has to be different, because you need a unique MAC address for each one of these. But in order to put them all on the same network, they have to use the same SSID. Otherwise, they just would not be part of the same network. And so when you extend a name across a multiple access point, you're using an extended service set, or ESS. Having multiple access points with the same SSID is what allows you to roam around in the building. As soon as you get out of range of access point A, let's say it's broadcasting on channel 6, and you get handed off to the next access point as you wander down the hall, the MAC address is going to change, because it's a different box, a different unit, but the SSID is going to stay the same, and it has to in order for roaming to work effectively. A lot of this you can change if you've ever browsed to your configuration page at home. Obviously, a business class access point is going to have a lot more options than this, but I just want to show you something that you're probably familiar with. You can change your SSID to be a name. You can make it something silly. No hackers allowed, or free porn here, or stay off my network. People call them crazy things. And you can also change the channel. In fact, in the picture here, it's set to 9, which is ridiculous. Nobody would ever set their channel to 9. That's just being perverse. And then the MAC address, which is the same thing as the BSS ID. I said there were different flavors of 802.11. Anything that starts with 802.11 is a Wi-Fi standard. There are different versions of the Wi-Fi standard that obviously have improved over time. G was very popular. Well, B is what I started off with, but G was very popular. N is probably has the most number of users out there right now, but more and more companies are switching over to AC. There is a new one, if you're wondering, in develop called AD, and they just have letters for the version numbers, if you will. If you're wondering where H is, or I, or J, or M, those were simply standards that weren't ratified. They weren't standardized, if you will. They went out as RFCs, but they were never approved. So that's why we skip a lot of letters. For my exam number 2, I want you to focus on 3 versions: G, N, and AC. The book, because it's a little dated, still says that G is the dominant standard. I don't think that's the case. N was certainly the fastest growing standard a couple of years ago, but a lot of companies are switching over now. And some other differences between the two. That 802.11n, if it's dual band capable, can use both bands, the 2.4 and the 5 gigahertz band. You can't do that with a 802.11g access point. The channel bandwidth is different, just the width of the band, the width, how many frequencies are used per channel. It's 20 megahertz, not gigahertz. Megahertz width here, and 40 megahertz width with 802.11n. Speed, of course, is what most consumers care about, but as network professionals, I expect you to care more about distance limitations than speed. If you're actually getting 54 megabits per second, that's not bad, but of course that's only half as fast as an old Ethernet 100 megabit port on a switch. And 100 to 600 is obviously a lot faster. However, your actual throughput, as opposed to your rated speed, your actual throughput is really going to vary, distance being the biggest factor. And remember, distance is going to affect things exponentially poorly. So the signal is going to degrade according to the inverse square law. And you can test this out at home. In fact, you probably already have when you move around your house. The further away from your access point, your signal quickly goes down, which means your speed goes down. And it'll tell you in the system tray exactly what speed you're getting, and you'll see it stop down, down, down until you lose signal. So even more important than speed is distance, that the typical maximum distance is supposed to be over twice as good as with G. Well, the reason this is so cool from a business point of view is I need fewer access points now, right? I don't have to buy as many to cover the same amount of square footage in the building. So that's cool. Another difference between G and N is the use of MIMO. Some people say MIMO, I say MIMO. I'm not an expert at MIMO technology, but I'll show you a slide just to give you a sense of how this works. That it allows you to send more signal over the same channel by using the two antennas and kind of the space between the antennas on your access point, like this. So there's something called a spatial stream, which just involves the space between the two from point A to the tips of both antennas here. That I'm not an electrical engineer. I just accept that you can transmit 2 signals on the same channel this way, and that's one of the things that makes N better than G. And now we come to the third version of 802.11, version AC, that I want you to be familiar with. I used to have this slide in green, but it's gotten so important lately I've switched it to red, and I do test you on this. It's the newest ratified standard. People refer to this, at least in trade magazines and newspapers, as gigabit Wi-Fi. You'll see why here in a second, because the throughput is supposed to be from 433 megabits per second up to a gigabit per second, so hence gigabit Wi-Fi. It varies with distance, and of course your actual throughput is really going to. Some points I'd like you to consider before you think about making the jump from N to AC. Now, if you do this at home, it's a no-brainer. That's fine. But in the workplace, you have to really give it some thought and come up with an elegant design that's going to meet the business needs of your organization. So the first thing is to kind of set the expectation with everybody that even though it's called gigabit Wi-Fi, you're not going to see gigabit speeds. You're going to see something in this range, which is still impressive. Although when you compare this to a gigabit Ethernet port, again, a wired connection is always going to be faster and always going to be better, always more stable, always more secure. Wired is better than wireless, but this is not a shabby speed if that's your actual throughput. Ripping out all of your access points and replacing them can be expensive. So some people do an overlay network, which means you just have two networks running simultaneously. So you kind of gradually add new access points, and then once you've got them all in place, then you take away the old infrastructure. But trying to rip out everything and replace it in a weekend, including making sure every wireless NIC, remember that's piece number 2 that you need for any wireless network, replacing all the wireless NICs to be compatible with 802.11ac in all the laptops, every tablet, every phone. That takes some planning to make sure that everybody can support the new standard. So the only way to figure out placement for where the access points need to go, if you don't need as many of them, you still need to figure out where they need to go, and this is where the site survey skill is going to be critical, and that's why I have you do an actual site survey of Founders Hall as your homework assignment number 5. All of your APs, of course, to support up to a gigabit speed, it does no good to plug them into 100 megabit per second switch port. You've got to plug them all into 1 gigabit switch ports in order to get the throughput, and which means you might need all new switches, or at least need to expand or upgrade some of your switches to have more gigabit ports, and those are expensive. I did run across an interesting article that, harkening back to using Wireshark, that if you happen to use a USB version of an 802.11ac wireless adapter, that does not work with Wireshark. Just a heads up in case you ever need to know. This last point, that the reason network architects like 802.11ac is not that you get faster throughput, but that you get greater density. And what I mean by density is one access point can support a greater number of connections than previously. So it's not that people are seeing greater speeds, it's that more people are able to connect to that same access point simultaneously and get at least the speeds they were getting before, if not better. So that's the architectural advantage of AC from my point of view.